Hi, good morning, everyone. My name is Jeff Caers. I'm a founder of MineralX, and really great pleasure to welcome you today. It's only a year that we founded MineralX, and we had a launch symposium last year, and many of you were there, but we have also a lot of new faces, so very much welcome today. So I'll start off with just kind of give a broad overview of how things are. And so the way I approach this problem is I had many meetings with you over Zoom or in person, and there were a lot of frequently asked questions. So I'll see what those questions are and then actually answer them. So a lot of you are asking, what is MineralX? Well, we are a diverse set of people, and I think that's relevant. It's the Pride Month of June, and diversity really is core to what we do, and we believe is also core to the success and what's happening, needs to happen in the mining industry. We need to bring more people to this game and to these problems. And I think we're a group that works on mineral exploration, but very few of us have any particular experience in mineral exploration. We have experience elsewhere. And that experience elsewhere is what we bring to the table and is where we collaborate with the experts in the field. So we have a number of faculty leaders, which are very different people themselves. Michael Kochendorfer is a professor in computer science. He's co-director now of the program and very much into artificial intelligence and sequential planning under uncertainty. We have Rodney Ewing, a long-time standing faculty member in mineralogy in our Earth and Planetary Sciences department, who has a long history in uranium production and waste storage. Rod is definitely a person we rely on in terms of giving advice around the geological part. We have David Yin, who some of you know very well, if you've been talking to. So David is essential to our program as a program director. And then we have a number of people who are our foundation. To do research and to run a program like this, I think it's very important to have research associates or senior research associates, people that are not getting degrees or that actually staff members, and so they're really very important. So then we have expanded significantly since last year in recruiting a number of postdocs, and there's a huge variety here. I'm calling out Duncan, who used to work for Amazon until last year, a high-level engineering position, and thought that there was also interest in doing something around minerals, so that's fantastic. We have PhD students, a mix of students from Earth and Planetary Sciences. We will have our new incoming student, Gloria, as our first mining engineer in the program, as well as computer science students. And then also we have very enthusiastic master's and undergraduate students who want to work with us in this. And as you see this, last year we had probably 6 people, and so now we have expanded dramatically. And then last but not least, Daniela, who has been arranging everything and is our MineralX hero in terms of getting the administration's part done. So then, of course, the question is, well, what are you unique in, right? There's many excellent programs in the United States and elsewhere around minerals, economic geology, geophysics, etc. So I thought of this, thought about this long, and I think that the uniqueness lies in bringing a scientific method to discover critical minerals, and particularly a scientific method that is based on 2 founding principles. That one of falsification by Karl Popper, and then of probabilistic inference by Thomas Bayes. I believe strongly that research should start with philosophy, right? After all, we are getting all PhDs, and that this philosophy will determine how we formulate problems to solve and how that then translates in specific algorithms or methodologies. So let's talk a little bit about falsification. Not because it's just a very important principle, but also because it had immediate effect this year in some of the work that Cobalt has done and the characterization of the very high-grade resource in Zambia. This principle of falsification was essential in doing that. And so in falsification, Karl Popper said that in science you can't really prove anything correct, but you can only attempt to prove things to be false. This is essential, I think, in our field where making geological hypotheses about the mineral, about the processes that create these mineral deposits are essential, but these hypotheses may not be true. And so the first order of business in this mineral discovery was around trying to prove some of the hypotheses that were made wrong. And there were many hypotheses made, and many of them were wrong. And so knowing that is essential to reduce drilling costs, because if you drill under the wrong hypotheses, you'll waste a lot of money. The second part is that of Bayesianism. So Bayesianism, which is referred to Thomas Bayes, who was a reverend living in the 18th century, but Thomas Bayes was a reverend more interested in drinking games, and so he came up with a rule that was based on billiard drinking games. So there's a more honorable introduction to that was by Pascal, who formulated the probability theory around that. So many of you, and certainly I was educated in the area of statistics, which is now called data science, at a time in the 90s, which did not use Bayes much. And I'll talk about that why. In a classical inference, we look at data, right? We look at data, we'll try to infer things from data. For example, maximum likelihood inference is one of those principles. But what Pascal and Bayes said is that there's more than one principle. There's a second principle or second requirement to do Bayes or to do probabilistic inference, and that is also look at the prior distribution. And the prior distribution can be those prior distribution around these geological hypotheses that I was talking, and that is essential. And so data and how that relates to hypotheses can be sort of formulated in this Bayes rule and was essential also in application to the Mingomba deposit. So why was that not around in the 90s, Bayes? And why was that not popular and was only popular very recently? And that has to do with computers. This is one of the characters, John von Neumann, in the Oppenheimer movie. He was just briefly mentioned. And he built this EDVAC computer that was the first computer to do Monte Carlo simulations. And so Monte Carlo simulation is the way we solve Bayesian problems. But of course, Monte Carlo simulations, because we have to do them many times, they are very computationally demanding, and these machines just cannot solve those kind of problems that we're solving today. So, but today we don't have John von Neumann, we have this guy, which you all know from NVIDIA, who's making all the money based on all the Gen AI today, and developing these chips, the GPU chips that really can leverage high-performance computing. And Monte Carlo and high-performance computing is a marriage in heaven. And so now we can do simulations at the speed that is tens of thousands times faster than we did even 20 years ago. And that has really enabled massive computing, which is done in many of our projects. There's underlying all of it is massive computing. So that is something I think we bring very much new to this space. So I haven't mentioned AI. Well, I've mentioned AI just a little bit here, but what about AI, right? AI is, to me, it's not a formulation of a problem. It's not a scientific method. It's a tool, right? So it's an algorithm. So for me, that comes in the third of the series. And what we use and what we do a lot is to use AI to accelerate this Bayesian computing. So we use AI to, for example, build neural networks that can replace a physical model, or build neural networks that can make predictions, or using AI to do sequential planning under uncertainty. Right? Underlying all of that is actually the Bayesian formulation. So the AI itself is not a scientific method, and neither is an AI something that can formulate scientific problems. We still need humans to do that today. So there's a lot to say about that, and we'll, about the scientific method in general. We'll have a lunch chat with Michael Strevens, who is a professor of philosophy at New York University and wrote this excellent book. I highly recommend reading that, The Knowledge Machine. And he will talk about irrationality and how actually irrational thinking has been quite efficient in science, and talks more about the scientific method. So that's about Mineral X, and a bit what we do. There's also a lot of posters in the hallway of our students' work, and that goes more into these Bayesian computations and falsification and case studies. But we also have an industrial affiliate program, and that is very unique to Stanford, which is a program that is a mechanism for multiple faculty and multiple companies to explore broad areas of topics without being locked into a sponsored research project. And that allows us to really think very broadly and out of the box and come up with ideas that you would even not get funded by government agencies because they're really wild out there. So it's a fee-based program, does not fall in a particular contract. And so we engage with companies in that way through collaboration, workshops. We have Slack channels, there's lots of things happening. And you see this is also an open program, right? We're not hiding anything. You can see everything that's happening out there. You can see everything that's happening in here. And so very much welcome your presence. We've been able to attract a significant amount of funding over the years, and will continue to attract more funding. We have our top tier funders, Cobalt Metals, Bidra, and Aerocopper, and then other members in the program, also top tier members, Excalibur. We'll talk about Excalibur later on. And our other members will give some presentation later on today. Also, something that I've never experienced in my career is that our students have done startups. So these are startup companies that in a way fit, try to address this Bayesian computation problem, right? So computing made easy. Because it's great to say, let's do Bayesian and computing, but the problem is also, how do you do that, and how do you make computers accessible? Because I can do computing on a high-performance cluster at Stanford for free. If you do that for your company, it's going to cost you, right? Because Amazon is making money out of what you do. Then we have Terra AI, is looking at sequential planning on uncertainty on a broad set of critical resources development, and I think all those are students, former students are present here. So, do we focus only on mineral exploration? The answer is no. In our team and my research team over my career, 25-year career here at Stanford, we're looking at anything that has to do with decision making or processes in processes or systems that involve significant uncertainty and significant variability. So not things that are very controlled, not interested in that. So one of the projects we're just starting, big project with Bidra and OCP and UM6P in Morocco, is around the phosphate value chain, the mining of phosphate creating waste and the processing creating waste, while phosphorus, of course, is an essential element to life on our life on this planet. So what we bring into that is, again, a better planning methodology, whereby we are going to now create gather data at various stages of this process. But of course, we want to be smart about what data we exactly acquire. And then we are also going to look at the various MPVs of valorization methodologies. There are many valorization technologies, and when you talk to the Moroccans, they say the problem is not the valorization technology. The problem is measuring the impurities and then determining what could be the valorization technology. And so that's a big project. We'll have faculty members visiting from GSMI this summer, and I will go there in September, and we'll have a whole group of 5-6 students that will be working on this project. Is Mineral X only about research? The answer is no. We're starting educational initiative around the world because we do feel that this work we do should be used by those countries that are actually doing the mining. So together with Cobalt, we have funded 10 scholarships in Zambia in a master's program and a revamped master program that I worked on with them together. And so in the fall, I will travel to Zambia and teach data science for the geosciences. The exact same methodologies that Cobalt is using in Zambia will be taught at the University of Zambia and the Copperbelt University, thereby empowering people there to use these methodologies. Another second major announcement is that we'll have another founding member joining our group, and that is the Bakri group in Indonesia. I had the great pleasure to present Mineral X for the President of Indonesia in Joko Widodo during the APEC in 2023. And that led to strong conversations around geothermal energy, of course, the minerals in Indonesia, but specifically focusing not on laterite, but on sulfide discoveries in Indonesia. And so with that, the Ministry of Education just recently approved the course that I will teach in Indonesia on decision making to develop earth resources, which actually will be is a book that we are writing, and so will be published early next year by Wiley. And we also have an Indonesian postdoc, Mansour, and he's been a tremendous enthusiasm, right? Another sort of diversity issue, right? We have so many different kind of students here at Stanford. When the president came, there was 50 Indonesian students showing up, and Mansour was very enthusiastic about that. Finally, or almost finally, we've been also involved in policy. I was able to testify before Congress, and we know the United States is a big challenge around mineral exploration and mining. And so they're starting to pay attention to that. There's a long way to go here in the United States, but I think the agencies are starting to think about that, DOE, et cetera. And we'll have Sarah Riker, who is the USGS director for minerals here today as well. And last but not least, we are of course very concerned about environment and community engagement. And we have Jonas Kluckner, who is a postdoc, will start with us this fall on a scholarship by the Human-Centered AI to looking at responsible critical mineral exploration in Brazil. And of course, he's Brazilian, so again, he's super passionate about his country. And Sophia, she's super passionate about community engagement, and she got a race scholarship at Stanford and went all the way to Zambia, spent 2 weeks with people there just asking questions about what they're thinking about mineral exploration, kind of having the lay of the land. And so that's also a very important topic that our students, our young generation is really worried about. So that's all I got. And we'll start the session off, and I call to the stage Kurt House. Thank you.